So we are on questions 7, 8, and 9 right now. And this time we are talking about tweezers. So the idea is that tweezers is one of the few examples of a third class lever. All right, so this is the idea where we're actually going to get less force out than we put in. So here we go. First thing again, once again, we have to draw tweezers, and if I don't want to embarrass you with my drawing ability, but I'm pretty good at it. Oh, look at that. No, you have to draw something, but I'm not. I'm going to be lazy and just draw it over here. So there we go. Here's my tweezers. All right. And the idea will be we need to draw and show that the whole thing, we have 4 inches is our, so we have 4-inch long total. So from the fulcrum to the end, which is where our resistance is going to be, because that's our outcome, that's 4 inches. All right. And we are going to have some kind of, same from our fulcrum, our effort that we have to put in. Okay. So our effort distance is going to be somewhere to about here. Okay. Depending on where we have to apply it. And we're going to calculate that later. Okay. And then it talks about a 1/5 of a pound of force is going to be applied. That's our effort, our resistance force. That's our outcome. So we have 1/5 pounds of force here, and our applied effort force is going to be in the middle here. That's where our fingers are going to be applied, and that's going to be 1 pound. 1 pound of force. Okay? All right. You need to draw better than me. You're welcome. Okay, so now let's get the AMA of the system. So we have AMA, MI free. MI free is going to be AMA is equal to FR over FE. Okay, we substitute in the resistance force is your outcome. Our outcome is going to be 1/5. Okay, so that's going to be on top. 1/5 is on top. And our effort force is 1 pound. They're both in pounds. So you have 1/5 over 1, which is really just going to be 1/5. So your answer is going to be 1/5 or 0.2 pounds. I'm sorry, not pounds. 0.2 will be just a ratio. All right, so there is your AMA. All right, now we have to use static equilibrium. And again, we're assuming that there's no loss due to friction in this problem. So we need to come up with the idea that, or you need to understand that we can then make the IMA equal to the AMA. So we have our IMA, which was DE over DR, is equal to our AMA, FR over FE. Okay? That's a really ugly F, but sorry. All right. So now we can substitute in. So we know the resistance distance. So our resistance distance down here is going to be 4 inches. Okay. Our effort distance is what we're calculating. We'll just leave that there. My I'm going to use my AMA here. My resistance force was 1/5, and my effort force is 1. But let me just fix that because that's just ugly. 1/5 over 1 we know is still the same as 1 over 5. 1/5. It's still 1/5. Okay. Now we're going to cross multiply. So I have, and I'm going to write this over the side, 5 times DE is equal to 4 times 1, which is just 4. All right, we can do our algebra. Divide both sides by 5. Yoink, yoink, that goes away. So my effort distance is going to be 4/5 or 0.8. So I will be applying a force 0.8 inches away. Okay, this distance here is going to be 0.8 inches away. That is it.